Alright, here we go. This is going to be rotations. Now, a couple things that are important about rotations. Okay, first off, there must be a center of rotation. In this place we're going to have the origin. Okay, remember the origin is a point 0, 0 on the graph where the two lines meet. Okay. Second thing we got to know is which way we're going. Are we going clockwise? Are we going counterclockwise? Okay, clockwise is to the right, like this. This is clockwise. Okay, and counterclockwise goes to the left. So this is counterclockwise. Okay, so we know which direction we're going now. Okay, now some other things we've got to know is this. Every time, for each time we go 90 degrees, each 90-degree rotation, okay, X and Y switch. Okay? I'll show you what I mean in just a minute by that. Okay, but remember, this is a very important rule here. Now, a couple things about rotations. First off, here we go. Okay, in math we start at 0 on the x-axis right here. Clockwise, this is 90. This is 180. Okay, and this is 270. Okay, counterclockwise, this is 90. Okay, those in parentheses, no difference. This is 180 still. This is 270. Okay, this is back 0. Okay, so the other thing that's important about rotations is that we need to know which quadrant we're going into, sign-wise. So this sign of this quadrant is positive, positive. This quadrant is negative, positive. This quadrant is negative, negative. This quadrant is positive, negative. Okay, so we need to know which side we're going into so we can make adjustments. Alright? Okay. Now, there's also two rules for rotations. Alright? The first one is a clockwise rule. Okay, so clockwise we're going to go X, Y, rotates to Y, negative X. That means the X is changing signs and the Y is not, they're just changing places. That's what this means, each of them switch. And then there's counterclockwise. Okay, so we go X, Y, rotates to negative Y and positive X. Okay? So, these are the rules for every 90 degrees rotation. So 90 degrees here, 90 degrees clockwise here. Okay? Alright, so let's see how this happens. On this shape, my final figure, or my original figure, is points at negative 5 and 1. So negative 5 and 1. Now, if I rotate this counterclockwise, 90 degrees, it's going from this quadrant into this quadrant right here. So it's 90 degrees counterclockwise rotation. Okay, so this point at 5, negative 5, 1, we change the thing and go negative 1, negative 5. So this point goes right down there. Okay, it becomes negative 1, negative 5. Alright? Because we change X and Y places, so I know what quadrant it's going into. It's 5, 1 going into this quadrant, so it's got to be negative 1, negative 5 to stay in this quadrant. Okay? So this point is negative 1, negative 5. Now, that fits my rule perfectly because this is a counterclockwise rotation, so it's this rule right here. And so the X was negative 5. It went to the back and stayed at negative 5. The Y was a positive 1, but it came to the front of the bracket and became a negative 1. Okay, so the opposite of 1. Alright? Okay. Okay. 270. Clockwise rotation. Clockwise. We're going this way. So this is going this way. And I'm going to do it this way. And my final answer is going to be when it fits in this quadrant. Okay, so a little secret we need to know is that 270 clockwise is the exact same thing as 90 counterclockwise. And 270 counterclockwise is the exact same thing as 90 clockwise. Now, normally in the real world we don't care which way you go, okay? But Alex likes to care, and then sometimes we do have to matter which way we're going. We have to know which way we're going, okay? All right, so we're going 270 clockwise. All right, so this point right here, we're going to do this point. Okay, that point's at 4 and, no, I don't want to do that point, that's boring. We're going to do this point up here. Okay, sorry. 4 and 6 is that point right there. Okay, so I'm going to rotate it 3 times. Now each time I got to flip my 90, so the first rotation makes it come 6 and 4. But in this equation, in this quadrant down here, this quadrant is positive negative, so that means it's got to be a negative 4 right there. Okay, and then I rotate one more, so I got to flip 4 and 6 around again, so 4 goes first, now 6. And in this quadrant, everything's negative, negative, so that means these would be negative 4 and negative 6. Okay, and I got one more rotation, so it goes one more time, so again, 6 and 4 change places. But this time, this is a negative 6, and this is a positive 4, this rotation. So there's my final answer right there. All right, and so then these questions are, if the 2 lines are parallel in the original figure, then those 2 lines may not be parallel. We know that's false. When a figure is rotated, single measures stay the same. That's true. And figures rotated, the final side lengths are larger. That's false. Okay, so a lot of information there. We're going to use that. Okay, so rules or degrees in science. Okay, so on Alex, on this problem here on Alex, your job is to grab this rotation bar and rotate this around so it fits there. So we're going to rotate this around so it fits right on top of it. Make it fit. Can't make it fit, it's got to be not possible. Okay, and this way we don't care which way we roll this. We can roll it this way, we can roll it this way, don't care, just make it fit. Okay, alright, now our last one. This is, we're going to do this by hand. We're going to move this shape. Okay, now before I start, I gotta look what I'm doing. I'm doing 90 degrees counterclockwise, so that means I'm going this way. Okay, counterclockwise. Alright, so that means that this shape, we're going around this way, so this point here is going to rotate up to this quadrant up here. This point is going to rotate to this quadrant over here. This point is going to rotate this quadrant. So these two, this one point is going to be in the first quadrant, which is, again, is positive, positive. And these 2 points are going to rotate into the second, into the fourth quadrant, which is positive, negative. So I know what my sign is going to be already. Okay? So let's just move our numbers. And again, we're doing 90 degrees, so that means X and Y are changing places. So this point here is at 1, negative 4. So change those places. I go to 4 and 1 and put that point right there. That point is 4 and 1. Okay? Okay, this point is at negative 2 and negative 1. Which means I change those places, I go to 1 and negative 2. So this point right here is right there. It's at 1 and negative 2. And then again, last thing, my last point over here, it's at 5 and negative 5, negative 3. So negative 5, negative 3. It's going to translate to positive 3, negative 5. So it's going to be right there. So when I translate my point, or I rotate my point, sorry, my rotation puts my triangle in that form shape right there like that. Okay? So, rotation's not a bad deal. You just got to be very careful how you do it. Okay, and again, I like to know which quadrant I'm going into, and I'd like to know the signs of each quadrant as I go into it, so I know at this point, it's going 9 degrees to this point. If it goes 180 degrees, it goes around to this point. Okay, 270 will be back around to this one over here. I just know where it's got to go. Okay, all right, and I just use my rules and my 90 degrees and my sine chart to know where things are going. Okay, and just be careful where you go with them. All right, we're good.